Hey guys, let's go ahead and start with Chapter 10.1, Hypothesis Testing. Chapter 10 can be kind of rough, so take your time, ask me questions, and I'm making these videos to help you with everything, and hopefully it'll make sense. So let's talk with basic stuff about hypothesis testing. A lot of you have probably heard this before, hypotheses, when you think of science. And it's basically the same kind of thing in statistics. You're testing something. So let's go ahead and start with this PowerPoint and talk about it. Okay, you have two hypotheses, the null and the alternative. So you're testing, the hypothesis testing itself is you're testing a claim about a population parameter using statistics principles. The alternative is denoted by H with a subscript A. It's a mathematical statement that describes a population parameter. It is the hypothesis that the researcher is aiming to gather evidence in favor of. It is also referred to as the research hypothesis. So the null hypothesis denoted by HO is the mathematical opposite of the alternative hypothesis. It will always include equality. So hint, 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 that's a big one. That means it's going to have some form of the equal sign in it. Okay. So determine the null and alternative hypothesis for the following scenario. At Northwest Mississippi Community College, syllabi for online classes state that students should expect to spend 10 hours per week doing coursework for each 3-credit-hour class. The director of e-learning for the community college is concerned that students are being required to spend more than 10 hours per week doing work for each 3-hour class. In order to determine the hypothesis, we're first asked ourselves, what evidence does the director want to gather? The learning director's concern is that the students are being required to spend more than 10 hours than, of course, work that the syllabi states. Hence, she's investigating whether the mean is greater than 10. So therefore, she's researching that the mean is greater than 10. And the logistic opposite of the hypothesis is the mean is less than or equal to 10, which is the null. So think about it in terms of your null hypothesis, which is usually the one that goes on top, is the mean is less than or equal to 10. The alternative, which is the hypothesis you're testing, I can't stress it enough, remember, alternative hypothesis, you'll always be testing that, is the mean is greater than 10. So look up in that null, you see the equality sign because it's saying equal to or less than. That's where the equal sign is. Okay, and we denote the mean with the little mu symbol, and 10 is the number that we talked about. So the mean is less than or equal to 10 is that null. The mean is greater than 10 is the alternative. Okay, let's do another one. Determine the null and alternative hypothesis for the following scenario. After learning that Peter Coulet of Switzerland could hold his breath for 19 minutes and 21 seconds underwater, wow, a group of students decided to conduct a science fair project around the amount of time an average adult can hold his or her breath. Part of the group found research to suggest that adults can hold their breath for up to 30 seconds when submerged in lukewarm water. The other half of the group found evidence to suggest that the mean time is different if the water temperature is cooler. The group would like to test the claim about adults holding their breath in cold water. All right, so what are they trying to find out? They're trying to find out the time to hold your breath underwater. So we're going to say about mean because it's the average amount of time. So, because what you do is you put like 25, 30 people, you gather the evidence and get how many seconds they can hold their breath underwater, and then you find the mean of that. So we're going to say that they're investigating whether the mean amount of time that an adult can hold his or her breath underwater when the temperature is cold is different from the reported time of 30 seconds when the water is lukewarm. So they're not interested in if it was above it or below it. They're just interested if it's different. So we're going to write our alternative, which is our research hypothesis, is the mean does not equal 30 seconds. Because they don't care if it's above it or below it. They just want to know it's different. So that's when you give it that not equal sign. So that means the null is the mathematical opposite, so that the null is the mean equals 30 seconds. Okay, So determine the null and alternative hypothesis for the following scenario. The leading news authority claims that the president's job approval rating has dropped over the past 3 months. Previous polls put the president's approval rating at a minimum rate of 56%. The president's chief of staff is concerned about this news rate since the election year, and he wants to run a test on the claim. So the news authority claim refers to a population proportion, which we write symbolically as P, okay? So if you see that percentage symbol, use the P. The claim being tested is that the president's approval rating has dropped since the previous poll. Okay, so our alternative is that P is less than 0.56. So we just converted that percentage into a decimal. So we write that as alternative, and then our null hypothesis is P is greater than or equal to 0.56. If you have your alternative or your null hypothesis, you can make the other, because remember, it's just the mathematical opposite. Okay? One more scenario. Determine the null and alternative hypothesis of the following scenario. A survey of Super Bowl viewers found that 8.4% said they were influenced to buy products for companies that advertised during the game. Because of the rising costs, one company's president has threatened the advertising team with not renewing the Super Bowl ad spot unless they get the results they want. He says that unless the company's ad stimulates at least 8.4% of viewers to buy the product, then they will not be airing an ad during the Super Bowl next year. In order to determine the hypothesis, we're asked, what is the company's president researching? He doesn't want to cancel next year's Super Bowl ad unless there's evidence to show that that viewers aren't buying the company's product. So you're going to say that because we see it's a percentage, so we're going to test, is it lower than 0.84? So that's our alternative. So our null is P is greater than or equal to 0.084. So because he wanted to test that if it's lower than that, then they're not going to buy it. You could see where people could get confused and say, well, doesn't he want to test if it's greater than that? But the problem actually said that it was less than that, and that's what you're testing. Okay, so a test statistic is the value used to make a decision about the null hypothesis and is derived from the sample statistics. A sample statistic is said to be statistically significant if it is far away from the presumed value of the population parameter to conclude that it would be unlikely for that sample statistic to occur by chance if the null hypothesis is true. That's a huge mouthful. Let's break it down into parts. You can say a sample is statistically significant, which means that it is far away from what the population's parameter is saying, and it's unlikely that it would occur by chance if the null is true. So the level of significance is denoted by the little alpha, and it is the probability of making the error of rejecting a true null hypothesis in a hypothesis test. So alpha equals 1 minus C. So let's talk about that again. It's the probability of making an error of rejecting a true null hypothesis. Okay? There's only two ways to conclude a hypothesis test. You can reject your null or fail to reject your null. Okay, so let's see what this says. At Northwest Mississippi College, we'd already talked about this, and we said that the e-learning director is concerned that students are spending more than 10 hours per week. A hypothesis test with a 5% level of significance is performed on the director's claim. The result is to reject the null hypothesis. What do you conclude? Okay, so remember we did this back then. We stated our null and our alternative hypothesis. Okay, but now we're saying that the null hypothesis is rejected. So if your null is rejected, that means you're accepting your alternative hypothesis. So the e-learning director can be confident in her assessment that students study more than per week on average than the time stated with a 5% level of significance. All right. Let's do another one. Based on historical data, the Board of Education for one large school district believes that the percentage of high school sophomores considering dropping out of school is at least 10%. A high school counselor in the district claims that the percentage is too high. A hypothesis testing with an alpha of 0.02 is performed on a counselor's claim. The result is to fail to reject the null hypothesis. Do the findings support the counselor's claim? So the counselor is saying that that is way too high, that 10%, that less than 10%. So we're going to look. So because the research hypothesis, or the alternative, is written that the p is less than 0.0, then the opposite of that is the null, which is p is greater than or equal to 0.1. So we state our hypothesis. If we fail to reject our null, that means that we're keeping that null. So it says evidence is not strong enough at this level of significance to support the high school counselor's claim. So if you reject your null, if you fail to reject your null, you mean you're keeping your null. And it means that our research hypothesis wasn't true. So all you say is there isn't significant evidence to reject the null. Okay? I'm going to stop there and we'll keep going on the next video.